I'm going to illustrate the operations of the Combat TB Workbench. So I've gone here to the Workbench server. I've put in my user credentials. I will now log in. Recent activity shows some analysis that has been happening. And you see over here, I can browse projects. So there's 2 projects with data already loaded. You can create new projects here in the corner, but I'm not going to use that right now. So let's have a look at this data. Here are some samples that have been loaded into the Workbench. If I look at the line list, these samples have already been analyzed, and I can see the metadata that has been computed by the per sample analysis script. If I look at an individual sample, then I can see its paired end reads. I look at each set of reads, and I can see a quality control report on the reads. This definitely looks like good quality here. Going back to the samples, I can select some samples and add to cart. That takes me to the place where I can now analyze the samples. So if I click this, then I see the various pipelines. These 2, the phylogeny pipeline and the sample report pipeline, are the workflows that are part of the Combat TB Workbench. These other pipelines come built in from the iReader group, but they are not ours and they're not functional on the server. So if I look at this pipeline, this is going to run one pipeline for each sample that I've got in my cart over here. Okay, so there's my 4 samples. I'm just choosing the pipeline again. So I've already computed line list metadata for these samples, but if I hadn't, then I can select that so that at the end of the analysis, the results are saved back to the line list. Down here, I have a choice of 2 reference files, my MTB inferred ancestral reference and the 837RV assembly, which I could choose as a reference sample for my analysis. Here are all my various samples. And over here, if I want to, I can modify the parameters. So, so which minimum fraction of samples am I going to, so 0.1, in other words, at least 10% of reads must support an allele to be accepted. But down here, I see some other options related to, for instance, the operation of TB profiler, and so on and so forth. These are different parameters of the Galaxy workflow that underlies this analysis. So I'm going to click that button again to make it go away, choose the default parameters, and then click Launch Pipeline. When I do so, then you can see these are queued, and in a few seconds they'll switch to running, and so on and so forth. Okay, this is the view of my analysis window. So if I click on analysis, your analyses, then this is exactly what I see. So now it says submitting. While I'm doing that, I've still got these 4 in the pipeline, but let me go here and say empty cart, and then I can go back to the collection as a whole, select all samples, or select none. So let me select some different samples, or I can select some of the same, add to cart. And while it's busy running these analyses, I can actually start the phylogeny pipeline. Now, the phylogeny pipeline takes multiple sample input So it's going to have one output report, whereas the other pipeline will have an output report for each sample. So I would limited capacity on the server, but I can still click launch pipeline. And now, because it's a single output, it shows me just the one analysis in this state. Okay, so if I go back to the analysis view, then you can see that these 4 are running, taking up all of the virtual CPUs on the server. I'm not sure if there is enough capacity on the server to run the phylogeny at the same time as the individual samples. Going back to the projects view, if I wanted to, this is a sample that's actually shared with me, then, but if I wanted to, I could add new samples. I could create a new sample and upload some data. Obviously, in practice, you want to upload bulk data, and it's much easier to do that from the server that's hosting your sequence data using the iReader command line uploader, which I will not demonstrate here. Once the analysis is complete, it will show up here. You see this is still in the running stage, but once it is complete, it will show up here, and you can look at the results. So now we, some minutes later, this workflow is still running. Let's go have a look at our other analyses. So we see that this one analysis has completed, and because that completed, then the phylogeny pipeline started running. And here is the completed analysis. We can see the TB variant report, which is a text report on all of the variants that we found in the chromosome of TB. And we see here the gene. This is in TSV format, so it says text as mostly tab separated here, except for the header. It's identified the lineage based on which SNPs have been found. This information is in fact on TB Profiler. And we can see here what type of variant we're looking at, so a synonymous variant, what the change is. Obviously, there's no change in amino acid here. And if something is known about the gene where the SNP happened, then the information is here. And so on and so forth for all of the SNPs. Gives us some information about the SNPs. Here is drug resistance prediction report from TB Profiler, and we see that this sample is resistant to these drugs. This is the percentage or the fraction of reads supporting this conclusion and what the variation is, CAT-G mutation, suggesting isoniazid resistance, and so on. Some statistics on mapping, so 99% of reads mapped. And then the raw VCF, if you want to look in more detail, this is the VCF annotated with SNP-EFF, the raw TB Profiler report, and so on and so forth. And then this is the inferred sequence after insertion of the variants. If we want to, we can download all files or individual files from this report. There's our analyses. We can see that 2 have now completed, some are still running. Okay, that was a quick introduction to the Combat TB Workbench.